Hi guys, I wanted to go over my solutions to the virtual VirSecCon CTF web challenges. So this was a really good CTF, and this is what I'm going to do the walkthrough. Start with countdown. So warning, a bomb is about to go off. Click here to defuse. Too late. Strange. Let's see what's going on with burp. So there's not many pages here. We make a GET request to this defuse page with a detonate time, and we fail. So let's just make this very big. Thank you, you saved this. Here is the flag. Hot access. This is a small program that lets you convert load convenient and simple HTTP resources from this Apache web system you can access. Cool, we're just loading stuff. We can pretty easily see this is probably going to be a local file include. So you can see that we have local file include. I already enumerated this over a fair bit, and couldn't find anywhere where I could insert couldn't find any files I could control to get RCE, and remote file include appeared to be disabled. But what you can do is actually just include the .htaccess file. View the page source as well. It has a directory var .hv flag is here. So if we go there, let's see what we get. Let's try flag.text, and we have the flag. Magician. So that appears to be MD5. Looks like we're trying to get them to equal this MD5 hash with a loose comparison. And this uses two tricks in PHP, and that loose comparison of two floats will be true. And these will be treated as floats because of the 0e. Well, this one will be a float, and we need to make this one a float. It's going to take an MD5 input, so we need something that is MD5 to a 0e. Of course, we can't also enter numbers because isNumeric must return false. So I just saved the bookmark for this. A little talk about magic hashes, different magic strings and their hash value with 0e's. It tells you if you use password 123, it converts to that in MD5. So look at that. PHP juggler. So we have the source code for this little application. Tell me the flag. So wrong flag. It's actually doing a string compare with what we post as the flag parameter with the value flag, which we don't know. We can bypass the string compare pretty easily. Let's go to burp, pull that request out. A string compare will fail if it's given an array as the flag here. So if we change our flag to be flag array, we'll get a string compare to be a string. Array was given on line 60. Because that fails, or it returns something that is, it returns something equal to 0, or it returns a return value of 0, we get the flag. Let's do this one. So this one had some interesting stuff. You can probably spider all these pages. I think one of the others gave you something. PHP these seem to normally redirect. The flag page didn't redirect. All these other ones did, except for I think one. Let me just see. This is 014. of them had a hint. Yeah, I'm trying to remember where the hint was. Hinted towards using a PHP filter. So this page doesn't redirect you, it gives you the flag. Looks again like local file include, but you'll notice pretty quickly that we just don't seem to be able to get anything back. It's just strange. But let's go to payload all the things. It's a great website, and if you do have or suspect you have a PHP local file include, let's see what you can do. File inclusion. A bunch of tricks, but we are going to use the filter convert base 64 trick. Just use the PHP filter to convert stuff. So let's go back to the flag page, set that there, and we want to convert the flag resource to base 64. Cool. Take that to CyberChef. Base 64. So we've got the contents of the flag page, and now we have it in a comment here. It's never displayed to us. JAWT. So if we have a look around, we see this website. It wants us to be the admin user, and it does give us a JWT to play with. So let's take that to JWT.io. So we have a username admin. It's a symmetrically signed token. We don't know the secret key. I tried a few tricks with like null algorithms here, but those failed. Turns out that it's actually just a brute forcing of the secret key. So let's grab a hashcat. That's the mode for JWT. Skip long passwords, just the hash, and where's my word list? Let a small word list up. Cracked, and where is it? The key was pocket. So if we enter in the key here, signature verified. We can now actually change this because we know the key. We can recalculate the signature. Go back to this website. Replace that with our thing, with our cookie. Refresh the page. We got the flag. Mask. Again, very similar one. We won't try to hide any secrets from you. We won't keep any secrets from us. This means no special characters, please and thank you. Strange. Let's play around with some special characters. Eventually, you'll probably find like I have a default attack for this, but that's an interesting one. Let's see what that does. It creates the 49. So if we go payload all the things. Server-side template injection is what's occurring here because of the curly braces. Well, it appears to be occurring. It actually tells us straight away. Did I close the challenge? It tells us that who are you? Are you Ninja? Referencing Ginger. So we already know it's a Ginger. So if we scroll down to the Ginger payloads, let's just do a dump all config variables. I mean, you can get RCE with this, but we'll start simple. Have a look at their configuration, and what do you know? They have inserted the flag as a secret key. So that could have been a lot harder if we had to get RCE. 10 character web shell. So it's going to take the parameter C. If it's less than 10 characters, the shell executes it, otherwise it's too long. Okay. So C equals ls. Cool, we have a bunch of files. I see the flag right here, and you can just cat it with a glob. I don't think that's the intended solution because there's all these directories. I think what you're supposed to do is keep it on the 10 characters and find it in one of the directories, which you would have to go, if you list all directories, that's a really horrible way to format it. Let's have a look at that in Burp. Okay, that's all directories with directory content listed. So if we search a flag, we can see it's in this directory, E61. We take E61, that is, as far as it starts, E6 itself is actually unique enough that only one directory starts with E6, which is what we want. You could then go cat E6, glob out the rest, so autocomplete it, and then cat everything inside it. E6 star, the wrong slash. Yep. That's less than 10 characters, and then you get the flag from that directory. SQLitis. First name, custom results, so try John. Cool. SQLitis, probably referencing SQL, or 1 equals 1, or 1 actually would be enough. Okay, we get all the results. Okay, this is going to be probably the hardest one if you ask me. So we can see all the results in database. We don't know where the flag is, and it's presumably in another table. So we're going to have to go. We'll start writing this in Sublime and making up our payload as we go, because there will be multiple steps. So we'll do like a John or 1. We know that works and gives us everything. So what if we say John or 1 ordered by 1. So that succeeded. If we continue this, we find out how many columns we're retrieving. Succeeded. And that crashed. So we know there's 3 columns. Order by 3, so we can order by 1, 2, and 3. If we do order by 4, it doesn't work because there's no 4th column in the select statement that we're injecting into. Now we actually want to do. We're going to figure out the types of the columns. So select John. Do all 1 union select. That should do it. Because we can see that it's like string in. Let's just try string int. And then we select our string int into theirs. Cool. Now let's get the table names, which is why I bookmarks here. Which is excellent. Basically, this is what I want. So I'm doing exactly what this site says to do. First, do the unions to figure out the number of columns. I'm only going here because I want to speed up this writing the SQL. They select the database and the version. Like I can do that to get some additional information. This will depend on. So we can see we're in 5.5 Ubuntu, and that's actually OS version, not database version. But I already run some of these, and I forget which one it was exactly. It's whatever this site actually used. So database name. We'll just ignore it. Extracting data. We can go now. Let's see how we can extract all the table names from a database, and it's this query here. So we want to select table name from information schema.tab. Is that spelled right? Should definitely be spelled like that. From tables, where table name is with database name. Oh, wait. How about we just copy this one, not the query. Yep. So we want to do that. So we want to go John or union. And we're actually going to go union select a string, table name, a random, just an int arbitrarily, and then select the table name from information schema.tables where table schema equal database. That gives us the current database. We're not going to worry about new render databases. We'll just get the tables in our current database. When union select one table name one from information schema.tables. Probably helps to put the comment on. Sweet. So we actually got 2 rows here. So we got all the table names with the customers one, which is what we're already on. There's a flag table. Cool. Now we want to pull data out of the flag table. We can just write that one ourselves, really. We don't know the name of the first. Actually, no. I'll say. We now want to get the name of the row, the table names, columns. Let's just take the example one here for columns. Clean it up a little bit. So we want to select an arbitrary string, a column name, and an arbitrary int from information schema columns where table name, where table schema equals database and table name equals flag. We don't really need that. So that should be our new nested query. Pop that in. Copy that in. Where did we go wrong this time? Union select one column name one from the columns where table schema database and table name equal flag. Yeah, I would have expected that to work. Some columns. Let's try it again. Never know. Weird. Might have copied something else in the clipboard. So value is the column name. So now let's just go back to our original one, and we will select one value from the flag, and we will limit 1, but I assume there's only one thing in that table. Then we get the flag. Easy. Let's continue. Dairy products. Get milk. Nothing else on the page. Has a bunch of stuff. I originally thought this was going to be some sort of server-side XSS in a client or something who opens this, but you do a bit of directory brute forcing. SQLi should have this. You'll find .git, and this looks like a Git project, and we can see like the configs and that for Git. But we can rebuild the Git project with this tool GitHack. So if we just SSH somewhere, yep. So we'll come in here and use the tool GitHack. We'll give it, just give it the address, and it'll rebuild the Git repository for us. So 142, and we can see a flag.txt. Easy. Irregular expression. As you can see here, well, it's pretty obvious. It shows a pattern I replaced with some text, and we are doing a regular expression on the text. The quick it got replaced with slow. If PHP regular expressions are pretty dangerous, so if you go to the documentation on preg replace, which we'll assume is getting used in the backend, if you look at the headers for this app, it is PHP. That's our pattern. We see that no, not noblet. You've just been owned. Exploit code. Yeah, so if we can play something with the E parameter, it means to execute it. You can look up the preg replace and we'll end up executing this command. So we change the I to an E and this to a system ID. With that we execute it. So let's just do an ls command. Flag name, don't guess please. Cool, let's try cat that. And we get the flag. Again, we now have code execution on the box. Do a lot worse if we wanted to. Crush. Hello there. Fun facts about sea turtles, as you can see. Fun facts about sea shells. It's referencing shells. It gives you something about the crush from the movie Finding Dory. Tells you about BNSSH crush. Bash dude was not much else here. I did a brute force on this. There's a few other things like status. Stats? Yeah, it gives you some uptime stuff. This is just a default CGI directory. I played around for a while before I decided to try putting the shell stuff together and shell shock it. So if we grab one of the requests in burp, and we go to save to GitHub this shell shock exploit, grab, so just doing it in the user version is enough in most cases. Let's change our user agent to a shell shock. We have code execution, so let's just do an. Oh, we can see a flag user, so home flag. Let's just have a look at their home directory. Okay, they have a flag.txt. Let's grab that. We got them with shell shock. Get encoded. Machines hunt for more than humans do. Not much here. One of the enumeration steps was to look at robots.txt, disallow debug. Let's have a look there. Go away hacker, no unsafe functions, insert query URL string. Did I do something wrong? Normally there was, yeah, a bit of code. Tells you what's going on. Can't have any of these. If you have a get parameter and you don't match the blacklist, it'll end up executing your function with its arguments. So if we try, and if debug is function debug, where is it checking? Okay, so if we I think that's just turning on debugs. If we do considering it's going to go in that, we want to do like a system or exec or something. So if we do a system equals ls, that should run system with the ls parameter, and we can't because we have typed something that's blacklisted. But if we encode system, we should be fine. I think that's just a thing. The server sometimes has resource issues. So far you can never guess. So okay, let's change this to a cat flag. Now we're hitting blacklisted characters again, so what I'm going to do is just URL encode this. The issue is that doing the request URI, so it hasn't been URL decoded yet, so nothing here will ever match the list, and we get the flag. ILS. Username, password, error, it's bad. I guess ILS kind of refers to like blind SQL. If we do an or one, we log in but no flag, so probably have to steal it similar to last time. To make this quicker, I wrote a quick, well, to identify the vulnerability, you would just go or sleep 5, and you'll see it takes 1, 2, 3, 4, 5, oh, about 5 seconds, maybe 10, it might be executing twice. Go away hacker, go away hacker. They can some of the tech that we're doing in SQL injection. So we can see we can create an oracle here. So you'd have to look up some of the guides and go to find SQL. I just did a quick Google and ended up on this oracle here. Might be better in burp. So we're going to go ASD or convert to ASCII, because otherwise we'll have case and sensitivity problems. Select the substring from, select password from users where username equals admin. It tells us to log in as admin on the hint. We want to pull, just because this is an example, we will select the first character and a length of 1, so the substring, the first character with 1 length. So we just increment this to the next character, the next character along, and we want to check what it's equal to. We'll go with 76, which is a capital L, which all flags start with. Let's run that. So if we're successful, we get that. So we now know the first character's flag is an L. If we were incorrect, say we did 55, we would get the hacker go away. So we're using the OR on the username to just get the login to be successful and cause the, and if our oracle is successful at creates true, we will log in and get a different error message, so we can actually not have to use blind and sleeps and that. We can just use a boolean based, and then I did it this way, so I just iterated up the characters, so for range in 32 to 126, which are printable ASCIIs, increase this, and if we hit a good job in the response, then we print it, we continue to next. We continue added this for loop into the next one, which is just iterating the positions in the flag. So if we run this, it will actually find the flag. If we use Python, it'll just take a really long time, but it can be optimized hugely, and I did that. I wrote this one in Go, and instead of doing character at a time, this one does binary search. So we're doing less than and greater than to halve the search space each request on every character, and I synchronize and solve every character in an asynchronous fashion. So if we do this one, oh, that's less than useful. Let's just die. Might have edited the code between. This is definitely a working version. So there we go. And we'll do this, yeah, I mean this takes forever. it will work. And meme factory. You almost don't need the source code for it, but this does help. So here's the source code for it. It's not a very big application. We can see they use URL lib 2 to download an image. I mean, if you play with the app, it's definitely changed a bit since I touched it. Top text, bottom text, pick a meme. Somewhere, where do I go now? Choose your picture. So it doesn't have to be enter key, but just press enter yourself. Site seems to be a little bit slow. It added my text into the meme. I think I got the wrong one. But if we look in burp at what's going on, we posted top text, bottom text, and a URL. That's strange. We probably have server-side request forgery. Pretty easy to confirm that yourself by changing that to a URL you can control. But what if we did like http://localhost? This is probably where the source code's helpful. You can see it's on port 50,000, so let's do 50,000. Most likely this will fail. Should have technically failed, because if we look at source code, it will actually only open it'll add HTTPS to the URL if it's not in the URL for security. We'll just add that to our URL just to make sure. So yeah, that looks better. It's not highlighted anymore because it's in a JPEG, which means it actually followed through with this code path here, and it did the request and sent it back to us as a temporary file name plus the JPEG extension. It's the last one. We could see it was HTML encoded, so it actually just returns the index page because this didn't have HTTPS in it. But again, not much is going on here. We're just getting the index page we already knew about. But if we go to payload all the things, because that is an SSRF, let's have a look at server-side request forgery. What can we do? One of the schemes is the file one. So file equals etc password. That's a good one to try. And again, we need to get HTTPS in this somehow. So if we just use a hash pound, we have local file disclosure. And then we need to find the flag. A few good places to look, it would be etc. No. Sometimes I just open my own Linux terminal and check. So yeah, this is actually printing the flag just very slowly. We'll leave it run for this. Let's get var self. Nope, sorry. Proc self environ. Let's get some information about the environment. Not sure what happens sometimes. The web server just falls over. Gets us some information about PHP pip, like variables. Nothing actually useful, but another good one to check is CMD line. And Python home John me web server. Let's have a look at the source code for the application, because the one thing we didn't know was the secret key. Can't actually copy this. There's something I think I can. Try that again. Cool, and we have the source code again, but this time we have the secret key, which is the flag. Easy, and that's all the web challenges for CTF.